Hi friends. In first part we discuss about Lewis dot diagram, octet rule, valence electrons, then ionic bonding. In second part we discuss about covalent bonding. In ionic bonding there will be transfer of electron takes place, but in covalent bonding there will be mutual sharing of electron takes place. That is very important. Okay, you just compare with covalent bond with ionic bond. In ionic bond, there will be bond will be formed between metals and non-metals. But in covalent bond, only non-metals are involved. Okay, then there will be sharing of electron takes place. Examples: O2, CO2, C2H6, H2O, and SiC. Okay, this is the covalent bond formation. Two big circles represents atom, small circles represents the electron. So each atom mutually give one electron. Okay, each atom give one electron and it will make a bond. What bond? That is covalent bond. Covalent bonds form when atoms share two or more valence electrons. Covalent bond strength depend upon the number of electron pairs shared by the atoms. Um, you see this picture. So in H2 molecule there will be uh, each atom share one electron. So two electron form only one bond. In O2 molecule there will be sharing of two pairs of electrons. So two bonds are formed. But in nitrogen molecule there will be three pairs of electrons are shared. So it forms a triple bond. It's just a simple concept. Okay, then covalent bond can be classified into non-polar covalent bond and polar covalent bond. First we see non-polar covalent bond. Okay, when electrons are shared equally, that is non-polar covalent bond. Okay, non-polar, that means there will be no polarity. So both atoms are same. Okay, then in non-polar covalent bond, electrons are shared, but unequal sharing takes place. Okay, in H2O, H is different nature, oxygen is different nature. Hydrogen is highly electropositive, but oxygen highly electronegative. So there will be lot of difference in their nature. So there will be polarity can be created. Okay, this is the pictorial representation for water molecule. So in water molecule, oxygen is a highly electronegative atom. So hydrogen donates its electron, not donate, sharing its electron to oxygen atom. Okay, oxygen atom, and it will make a covalent bond. Then characteristics of covalent bond: physical state. Depending on force of attraction between covalent molecule, the bond may be weaker or stronger. Thus, covalent bond compounds exist in gaseous, liquid, and solid form. Example: oxygen gas, water liquid, diamond solid. Okay, then electrical conductivity. In ionic compounds, that compound possess ions, so they are flowing in liquid state, so they conduct electricity. But in covalent compounds, they are not ions. Okay, they are molecules, so they don't conduct electricity. Melting point. It has low melting and boiling point compared to ionic compounds. Ionic bonds are very strong bond compared to covalent bonds, so it has low melting point except diamond and silicon carbide. Then solubility, so they don't have ions, so only soluble in non-polar solvents, insoluble in polar solvents like water. Then hardness and brittleness. Covalent compounds are neither hard nor brittle, but they are soft and waxy. Then Fajans rule. Um, in first part, we discussed ionic bonding, and now we discussed covalent bonding. So each and every compound is not neither ionic nor completely covalent. Okay, for example, in sodium chloride molecule, it is not completely ionic. There will be some covalent character are also present. Okay, that is fact. So this exceptional case can be explained by using this Fajans rule. So in 1923, Casimir's Fajans found through his X-ray crystallographic studies that some of the ionic compounds show covalent character. Based on this, he formulated a set of rules to predict whether a chemical bond is ionic or covalent. Fajans rule are formulated by considering the charge of the cation and the relative size of the cation and anion. So these 2 points are very very important in Fajans rule. You just memorize it, so there will be very easy. Okay, when the size of the cation is small and that of anion is large, the bond is of more covalent character. Okay, then I explain later. Then we move to second point. Greater the charge of the cation, greater will be the covalent character. Okay, these 2 points are Fajans rule. Okay, so first one is when the size of the cation is small. So first condition is cation size is small. Then anion is large. Size of the anion is large. So அப்படி இருந்துச்சு அப்படின்னா that bond will be more covalent character. Okay, then greater the charge of the cation, greater will be the covalent character. So charge of the cation will be greater. So this is the explanation for this picture. So we saw three conditions. Okay, size of the cation is small, size of the anion is large. You see aluminum chloride, third picture. Okay, size of the cation small, size of the anion large. Then size of the charge of the cation will be greater. So that compound is more covalent character. So here aluminum chloride is a compound present, covalent character highly present in aluminum chloride compound compared to sodium and magnesium chloride. Okay, then we see about a third bonding type, coordinate bond. So in coordinate bond there will be a sharing of electron takes place, but only pair of electron takes place, sharing only pair. Okay, 2 4 6 like this. Okay, example NH4 plus. Here NH3 is a donor, so it donates electron to the acceptor H plus and it forms coordinate covalent bond. But in book only one example is given. NH3 donates electron to BF3. That arrow mark indicates the coordinate covalent bond. So in NH3, N possesses one lone pair of electron and donates its electron to the electron deficient compound BF3. Okay. Then characteristics of coordinate covalent compounds. Physical state, it exists as three states like solid, liquid, gas. Electrical conductivity, they don't have any ions, so they don't conduct electricity. Its melting point is greater than covalent compounds but not greater than ionic compounds. Then solubility, they don't have ions, so they don't conduct electricity and only soluble in non-polar solvents. Then we see about metallic bonding. This is not in your textbook, it's for your extra knowledge. Okay, so in metallic bonding, metallic bond are present. Okay, so there will be electrons are present. So in our house we use copper wire for electrical transportation. Okay, so electrical transportation, so there will be flow of electron takes place, so current will be produced. So that is one of the important point in metallic bonding, that is known as sea of electrons. Okay, there will be in metallic bonding we mainly discuss only electrons, so they are metals are mostly conduct electricity. Then application of chemical bonding. Okay, we discussed three types of bonding. Then what is the application of chemical bonding? It's very interesting. Okay, the air we breathe, the food we eat, the clothes we wear, நிறைய இருக்கு. ஸோ இப்படி எல்லா விஷயங்களையுமே கெமிக்கல் பாண்டிங் தான் இது இருக்குது. ஓகேவா? These are the main important application of chemical bonding. Then we see the remaining part in next video. Thank you.